This video will describe how to work with Onset's linear scaling data assistant software tool that works with both the free version of HOBOware and HOBOware Pro. This list that you see here are all the supported sensors, so any logger that's compatible with these different types of sensors would be compatible with the linear scaling assistant. The first three are for our indoor like U12s, UX120, 006 products. The S prefixed sensors after that are compatible with either the microstation device, the U30 NRC, or the FlexSmart modules are compatible with the H22, the energy logger. It's also compatible with the U30 analog sensor port. If you have that optional two-channel analog input, it would be compatible with that. It's also compatible with two of our smart sensors, the leaf wetness sensor and the soil moisture sensor, and I'll show you a little bit more about that later on in this video. So I have a UX120 006M connected to my computer. I have HOBOware, the free version, open, and again, this linear scaling assistant is available in HOBOware Pro as well. I'm going to click on Launch Device and get into the launch screen. There is a course specifically on the UX120, so I'm not going to go through the whole screen. What I want to show you is what sensors support linear scaling. You notice here, when you click on this little box, you have all of these different sensors that are available to choose from, or measurements. If they are a Onset supported or supplied sensor, there's no scaling required. It's already applied, so you can see the scaling is grayed out. The ones where you'd have to apply linear scaling is to any of the adapter cables. So again, the adapter cables are just voltage dividers, or there's a shunt resistor on the 4 to 20 milliamp cable that converts that input to 0 to 2.5 volts, which is the native input to this logger. So let's select the cable adapt 5, which is a 0 to 5 volt input, since we used that in our analogy earlier. And you can see now that I've selected cable adapt 5, I have my scaling button available. So we click on that, and this is where we get to the linear scaling assistant. And again, we're doing this as we're setting up the device. So we're going to click on Create, and this is where we can set our relationship. Our raw signal is in voltage or current or whatever the output of that sensor is. The scaled is our engineering units, or how we want the data to be represented in the data file. So again, we used a PSI pressure for our example. So we're going to say we're setting up a relationship that says 0 voltage equals 0 PSI, and 5 volts coming out of that sensor equals 100 PSI. And then we can change this to pressure and click on Save and click on Done. And now you can see that we have a little 1 in parentheses, and our LCD units for this device are listed in PSI. So that's how you use the linear scaling assistant when you're launching a logger. You can also apply the linear scaling assistant to already logged data as a post-processing function, and then you would save that as a project file. So the way you do that, here we offloaded a data file from a logger that was logging an analog voltage here. You can see it right here. These other channels, you can't select those because those are from a previous deployment. Those get retained, those names, but there's no data there. So we have a raw voltage channel. HOBOware sees that we are recording an analog signal because this is an analog logger, analog input logger, a UX120 006M. So it makes the linear scaling assistant available here for post-processing the data. So let's click on Process. Again, if we had more than one channel, we could select which one we're looking at. But here we just have the raw voltage. To use our previous analogy, if this was coming from a pressure transducer, we could say that this is actually, the 0 to 5 volts is actually 0 to 100 PSI. And then we could give that series a name, call it pressure, and create the new series. And now we have the raw voltage, and we also have a scaled series in engineering units. We can unclick the raw channel if we want to, and just plot this now. I'm going to not plot those internal events. Plot, and there's my data. Again, I was just connecting and disconnecting a source. So we can see here's our data scaled in pressure. If we want to save this, we would go to File, Save Project, and then give it a name, and it will retain this scaling. Otherwise, the next time we open it, it will be in voltage also. And if you wanted to confirm how what scaling parameters were used when the logger was launched, or what was used for the post-processing parameters, you go over here into the left into details pane, click on the little plus sign in front of series pressure PSI, and then down you scroll down through this list, devices, deployment info, series statistics, and here we have linear scaling parameters. If we click on the little plus sign, it'll tell us what was used to scale that analog input. One of the sensors that's supported by the linear scaling assistant is the soil moisture sensor. There's two different versions that we sell, the SSMD M005 and the SMC 005. And basically we have there's a calibration procedure. They come calibrated, but for some soils you need to follow that calibration procedure that is on our website to determine what your best measurement range would be for that specific soil type. Once you run through that calibration procedure and get those calibration values, you can use the linear scaling assistant to scale that soil moisture measurement per your calculations. So I have a microstation device connected to my computer here through my USB to serial adapter. I'm going to click on launch device. We can see the microstation is attached. And I have a soil moisture sensor attached to that microstation, SSMD. So you can see we just have that one sensor, and if we click on scaling, it will open the linear scaling assistant, and we'll click create to create a new series. And this is where you can put in what your values should be based on your calculations after following that calibration procedure. This linear scaling assistant is also available, just like with the other example, as a post-processing function. So if you find out that indeed you need to calibrate your data afterwards, in the plot setup screen, when you have a soil moisture sensor attached to your computer, and again you will see the linear scaling assistant be available as available data assistance, and then you click process and you get to the same screen, and you can put in that calibrated those calibrated values, and then when you plot the data you can save it as a HOBO project file in order to retain those that recalibration or that linear scaling relationship. Here we see some soil moisture data that we've offloaded. We're in the plot setup screen, and notice linear scaling assistant is available. We click on process, and this is where we can do our post-processing scaling as well.